In this video, we're going to be looking at real-life graphs of functions. So in this question here, we're told a Gaelic football player takes a free kick off the ground. The ball's height above the ground is given by the formula y is equal to 5x minus x squared, where x is the time in seconds the ball is in flight and y is the height of the ball in meters. And the domain is given between 0 and 5, and we need to draw the graph of this function. Okay, so in our table there we have time, and I'm going to put h then for height. Okay, so we're going to have to sub in all those values into the formula. So first of all, when x is 0, so y is equal to 5 times 0 minus 0 squared. So this will equal to 0. Do the same with x equal to 1. So y is equal to 5 times 1 minus 1 squared. This equals 4. Okay, so you keep this process going on. Likewise, if you have a Casio calculator, you can just use the table of values function in that. So you should end up with 0, 4, then 6, 6, 4, and 0. Okay, you just keep going on and on with the process on the right. Okay, so let's label our graph here. 4 and 5. Same here, so 1, 2, 3, 4, 5, and 6. Okay, so we're starting off with 0, 0. Then we have 1, 4. Then 2, 6. 3, 6. 4, 4. Then 5, 0. Now, for any quadratic, make sure it's a smooth curve. Okay, looking like so. So the ball is kicked up in the air, goes along, forms a quadratic, and then it comes down at 5 seconds. Okay, so make sure you just label your axis as well with time and height. Okay, let's have a look at some questions that come with this now. So part B, how long will it take the ball to hit the ground after it's been kicked? So we can clearly see there that is 5 seconds. It starts here, goes up, 5 seconds, it's on the ground again. So 5 seconds. Then use your graph to estimate the maximum height of the ball. So that's just the highest point of it. So that is around here. So I would say that's around 6.3 meters. Again, if you're 1 or 2 decimal places off with this, it's okay, because there's always a range of values in the marking scheme. Last part then, so how long was the ball above 4 meters? Okay, so I'm going to draw a line here at 4 meters. We hit the graph, let's go down. Okay, so we can see that the graph was above 4 meters here. So between 1 second, 4 seconds. So 4 minus 1, that'll be 3 seconds. And that's it. Okay, have a look at another one. So a farmer has 14 meters of fencing to make a rectangular enclosure. One side is x meters long. Form an expression for the area in terms of x. Now, this is a common question that comes up in the junior cert, and you need to be able to do it. Okay, so we're told that one side is x meters long. So that means the other side also has to be x. The perimeter then is equal to 14. Now, the other side, I'm just going to call that the width. Okay, so I can form an equation now and equal it to the perimeter. Because we know how to find the perimeter, we add up all the sides. I know that the perimeter is 14. Okay, so I'm going to have x plus w equals 14. So 2x plus 2w equals 14. Now I could divide by 2 here to make this a bit easier. So then x plus w equals 7. So then w is equal to 7 minus x. So the width is equal to 7 minus x. I'm just going to put that in at the side now. So 7 minus x and 7 minus x. So now my area, I'm going to call that a of x. We know how to find the area of a rectangle. We just multiply the sides. So x times 7 minus x. This will equal 7x minus x squared. So there's the expression for the area in terms of x. Okay, part B then, we need to draw the graph of a of x in the domain from 0 to 7. Okay, so we know how to do this. So I'm going to sub in all those values. So putting 0, we have 7 times 0 minus 0 squared. That'll be 0. Subbing in 1 then. 7 times 1 minus 1 squared will equal 6. Subbing in 2. 7 times 2 minus 2 squared. That will equal 10. Now, we can also use the table of values function and the calculator for all of this. Save us a lot of time. And when we do that, we'll end up with 0, 6, 10, 12, 12, 10, 6, and 0. Okay, so let's plot these values now. Okay, so the first one we have is 0, 0. Then we have 1, 6, 2, 10, 3, 12, and then 4, 12, then 5, 10, 6, 6, then 7, 0. Okay, so let's draw this now. Remember, smooth curve, not using a ruler. Okay, last part then, for C, find the two values of x for which the area is 6 meters squared. So we'll go to 6, draw a line straight across, and then we'll go down. Now for this, you need to make sure you're using a ruler. So for this, we end up with x equals 1 and x equals 6. And that's it.